Hello, my name's Mark Saunders, and this video presentation is on probability sampling procedures. It's one of a series of YouTube video presentations on research methods and methodologies, and these can be found on my YouTube channel, Mark Saunders on Research Methods. Let's look at an overview of what we're going to talk about today. And before doing that, we need to remember that we only collect the samples when we can't collect data from the entire population. Today we're going to be looking at probability sampling, and we'll talk a little bit about what that means, and we'll also talk about sampling frames. And then we'll talk about 4 different types of probability sampling: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. And as you can see, these are all random forms of sampling, and the picture of the dice is there to represent this random nature of sampling. And finally, we'll finish with further reading. So what do we mean by probability sampling? Well, probability sampling is also known as representative sampling because it means the sample is statistically representative of the entire population. Probability sampling refers to a selection of sampling procedures in which the chance, or indeed the probability, of each case from our sample being selected from the target population is known, and it's not zero. So to be able to calculate a probability, we have to have a complete list of our population, or indeed our target population, and this requires a sampling frame. So a sampling frame, when we talk about this a bit more, is simply the list of the population. The choice of our probability sampling procedure involves a bit of subjective judgment because it's about choosing the most appropriate way of selecting our sample to enable us to answer the research question. The sample is then selected entirely at random using some form of random numbers. The most sensible way of doing this is either to use random number tables or more likely to use the random number generator on a spreadsheet. Probability samples are commonly associated with statistical inference, so inferring about a population statistically from your sample. So if we find in our sample 10% of the sample have a certain characteristics, we can refer that the total population has the same characteristic. It's therefore also likely to be associated with large samples, so large numbers of people or things being selected, because this allows it to be more accurate, and there's another presentation on this. The sampling frame comprises of all the cases or elements in the population, so all the people working in an organisation, all the cars a manufacturer produces, and it's from this that the probability sample is drawn. We can use existing lists sampling frames, such as, for example, a payroll, which is a pretty good one to use. Or we may use something else, but the trouble is that these existing lists are sometimes incomplete or inaccurate, or of course they can be out of date. We can also compile our own sampling frame. Examples of sampling frames include a list of employees, as I said, such as a payroll, a list of organisations members, such as an online membership list, as we can see illustrated in the picture, directories of organisations, or indeed purchase databases. Associated with our sample is this idea of sampling error. This relates to the random fluctuations that occur when selecting part of the sampling frame. So in effect we have our entire sampling frame and we select part of it which becomes our sample, and this is associated with random fluctuations which give us our sampling error. So let's look at probability sampling procedures. Our first one of these is simple random sampling, and we'll talk about this a bit more. Then we have systematic sampling, stratified sampling, and finally cluster sampling. And these all select samples at random using some form of random numbers. They also all select samples without bias, and that's because the random numbers are being used. But as I've said before, the sample will not be a perfect replica, as there will be some form of sampling error within the sample we select. Let's look at simple random sampling. This requires an accurate and easily accessible sampling frame, so that list of the total population. And for it to work, this list needs to be a population of over a few hundred if the sample is to be evenly dispersed. When it's smaller than that, we see groupings and then large gaps between numbers. And we'll actually see this in our later illustration of simple random sampling. It's often used to select samples from a larger organisation or club. And it's not that easy to explain if one's honest. So here we have a small, simple random sample of people, perhaps working for organisation. Now, we're only using 30 for illustrative purposes, but as I said, this would normally be a few hundred. So the first thing we do is we number all the people in our sampling frame. And once we've done that, we use random numbers generated probably by a spreadsheet to select our sample. Now in this case, we're going to select a third of our population as the sample. And as we have 30 people here, we need to have 10 random numbers. Using these random numbers, we then select our sample from the population using and you can see the numbers are listed underneath. So if we start off with this, we would select the first person, the fourth person, the 7th, the 8th, the 10th, the 18th, the 20th, 2nd, the 23rd, 27th and the 30th. As you can see, there's a little bit of clustering and then gaps, and that's, as we say, is a function of random numbers with a small population. We're now going to look at systematic random sampling. Systematic sampling requires an accurate and easily accessible sampling frame, but this time our sampling frame must not contain periodic patterns. So let's say we were looking at people who had joint bank accounts. Now, banks still normally list the people who have joint bank accounts in order of male and female, or if it's two of the same gender, male, male, female, female. So what this means is we tend to see a periodic pattern in our data, and if we're selecting systematically, this can cause problems. Systematic random sampling is suitable for all sizes of populations, unlike random sampling, and it's relatively easy to explain, as we will see. So once again, we have our population, and again it's smaller than we would actually be using in real life, of 30 people. And once again, we number our population, as we can see here. We then use random number sampling to select our starting point for selecting our systematic sample. As we're selecting a systematic sample of 1/3 or 33%, we need a random number between 1 and 3 to start with. So in our case, our random number is 2. So we select the second person, and then we take every third person after that. So we take the 2nd, the 5th, the 8th, the 11th, the 14th. And as we can see, it's very systematic. We're taking every third person once we've used that random number to ensure we have a random sample. We're now going to look at stratified random sampling. This requires an accurate and easily accessible sampling frame, but in this case our sampling frame has to be divisible into relevant strata, and by this we mean it has to be delivered into layers or groups. So if we were looking at an organisation, we might consider the different strata to be different departments or work groups. Once we've divided the sampling frame into different strata, we then use either systematic or random sampling within each of the strata we've created. What's really helpful here is we, like in organisations, having different size departments, but we can also see different size strata more generally, and so we can have different sampling fractions within each department. So for a small department in an organisation, we may take a 50% sample, or 1 in 2. For a larger department, we may have a sampling fraction of 1 in 10 or 1/10. As you can see by the amount of time I've been spending on this, it's quite difficult to explain, and obviously when we're dividing it into strata, we need to justify these in our methods section. We're now going to look at stratified random sampling, or as it's most commonly known, stratified sampling. And once again, we start with our population, and as I've said before, this is much smaller in the diagram than we'd actually have as a population. We'd probably be in the hundreds here. But the first thing we do when we've got our population is we create a sampling frame, and in this case we divide our sampling frame into layers or strata. And here what we've done is divide it into 2 strata based on gender, and we have males and females. Once we've got our 2 strata, we need to number within each strata separately. And then we need to select our sample either using random sampling or systematic sampling. In this case, for this example, we're going to use systematic sampling. And so we've selected a random number starting at 3 for each strata, and we're going to take a 1 in 3 sample or a 33% sample. And when we do that, we start with the third person and then we select all the way through every third person. And you can see this happening within each strata in this example. Random cluster sampling, or as it's more commonly referred to, cluster sampling, is the final of the 4 types of probability sampling we're looking at. And random cluster sampling requires an accurate and easily accessible sampling frame, just like the other ones. However, in this case, our sampling frame relates to clusters, not population members. So our population may be small business startups, but our clusters we could choose to look at these through would be incubator startups. So incubator centres where small businesses can start up. As before, we need a population as large as practical, and then what we do is we restrict our data collection to a few clusters geographically, and this maximises the amount of data we can collect face to face in a limited time. It's relatively difficult to explain until the clusters are expected, and then once we've done that, we collect all the elements from within it. So let's see how this works. We start off with our population, and here we can see our population here, and the first thing we do is we actually look at the population not in terms of the individual small business startups, but we look at it in terms of a series of clusters. In this diagram we've got 7 clusters. Next thing we do is we select our clusters at random using random numbers. So in this case we're going to select the second cluster and the fourth cluster. That then means if these clusters are incubator centres, we'll be in cluster 2, we'll be interviewing 6 small businesses, and in cluster 4 we'll be interviewing 3. So this saves a vast amount of travel time if we're doing face-to-face interviews, but there's still a random sample because we've selected them by actually using random numbers. I'd like to finish with looking at some selected reading. De Vals's book Surveys in Social Research has a really useful chapter on sample selection and in particular probability sampling, and that's chapter 6. Latpate and colleagues' advanced sampling methods goes into more detail of various aspects of probability in sampling. And the final reference is to my own book with Phil and Adrian, Research Methods of Business Students, and chapter 7 has a section on probability sampling as well as also dealing with non-probability sampling. Please do remember there is a whole channel on methods which I'm working on developing, and please do subscribe. Thank you.